Hello, and welcome to the first topic in our physics course, Uniform Linear Motion. In this section, we consider a body that travels through space with constant speed. Here we have Captain Omar, and this is his rocket. As you know, he has an interplanetary trip soon, and he is trying out his rocket before flying. First of all, he wants to make sure that his rocket will be able to maintain a constant speed when he is in space. To do this, he tries different velocities. At first, he makes his rocket go at a constant speed of 1 meters per second to the right. This means that for every second that passes, it moves 1 meter, like this. So, at second 1, the rocket has advanced 1 meter. At second 2, it will have advanced 2 meters. At second 3, it will be 3 meters. And so on. Now, let's look at this graph. Here we see time on the horizontal axis, which is given in seconds, and x in the vertical axis, which is given in meters. If we represent this in this graphic, the positions of the rocket are these blue dots. So, for the second one, we have our first point at t equals 1, and x also at 1. For the rest of the positions, we get these points, which together make up this line, which represents the position of the rocket at any moment in time. This means that if we want to know where the rocket will be at second 8, for example, we just go to the graph and we find that it will have advanced 8 meters. This can also be seen in this table, which represents each position depending on the time. Now, let's do the same thing, but for a speed of 2 meters per second. In this case, for each second, the rocket moves 2 meters. So, at second 1, the rocket moves here at 2 meters. At second 2, it moves 4 meters. And at second 3, it moves 6 meters. Representing again in the graph, we get this second line, which is still straight, but since the speed is higher, its slope is also higher. Again, we can see this in the table as well. So, let's look at these numbers and see what mathematical relation we can extract from them. As we can see, they both start at 0 meters, which is second 0. Then, for the first speed, we have that at second 1, the rocket has moved 1 meter. For second 2, it's moved 2 meters, and so on. For the second speed, we see that for second 1, it's moved 2 meters. For second 2, it's moved 4 meters. For second 3, it's moved 6 meters, and so on. So, going back to the first speed, what will the position of the rocket be at second 20? That's right, it will be 20 meters. What about for the second speed? It will be, that's right, it will have moved 40 meters. So, what have we done here? What did we do here to get these results? We just multiplied the seconds, or the time, by the speed. It is easy that the same applies for any speed. So for example, if the rocket is moving at 3 meters per second, this is what the graph will look like. And the values. So what we can conclude from this small mental experiment is that in order to get the distance, we simply multiply time times speed, like this. And we get these values. To make this a general relation, we see how distance, which we call x, is equal to speed times t. And from what we've seen, this works for any given speed.